Okay, welcome everybody to the Chippy Data SIG for today is May 19th. We have three great guests this afternoon. So we're going to open with Dennis Hume, who's going to be talking about Dagster. And then Ray Berg is going to discuss airflow and why we need job orchestration in general to set a little bit more context. And then finally, James Lamb will go over Prefect. So without any further ado, I'll let Dennis go into it.
Hi. So I'm Dennis. I'm a data engineer at Drizzly.
Sorry.
And I'm going to just talk about Dagster, which is a data orchestration tool that I've been using for the past couple months and really been enjoying. And sorry, but I've got some technical issues on my end, so I can't really do my demo, but we're going to go through this slide deck. So if we can go to the next slide. So what is Dagster? Dagster is a data orchestrator for machine learning, analytics, and ETL. It's similar to kind of the other presentations that are going to be happening today of Prefect and Airflow. If you want to know more about the kind of differences between Airflow and something like Dagster, on the Dagster blog, the creator of Dagster recently wrote a very long post about just kind of some of the differences, but I'm not going to focus on the differences right now. So next slide. So the basic abstraction layers of Dagster is the core kind of building block of within Dagster is a solid, which is just a function. You chain functions together in a pipeline, and that creates your DAG. Pipelines are run in different modes that define the behavior of the pipeline. So this can be things such as what resources they use and different configurations around that. Presets are just predefined definitions of how you want to run your pipeline. A big part of Dagster is parameterizing your pipelines and not changing codes to change the execution of your pipeline. You would just change your mode or your preset and then run it and then make changes at time of execution if you want to tweak variables. Resources are external assets used by pipelines, and this kind of relates to modes. So if you have kind of a setup of a testing environment and a staging environment and a production environment, you can set up different resources tied to different modes. So your pipeline will behave different when it's run in different modes. So maybe when you're running locally, you're just using just like a local Dockerized MySQL or maybe mocked out. And then in production, maybe you're connecting to your actual like cloud resources. And then a workspace is just a collection of pipelines that share either some kind of organizational grouping or dependencies between them. Next slide. So this is what a solid looks like. So a solid is just a Python function. It's pretty Pythonic, and it's just decorated with this Dagster solid decorator. So this is just a very simple solid that just raises a number to the second power. You can see that it leverages Python 3 type annotations. So in order to run this solid, you need to supply it with an actual string, and it needs to return an integer. If it doesn't pass those type checkings, the solid will fail, which can be really helpful once you start to get some very complicated pipelines that have a lot of solids and you want to track down an error and you want to just make sure that you don't proceed in your DAG if something's kind of not going as expected. Next slide. So this is what a pipeline is again, a pipeline is just functions stringed together. You can see that we're using that second power function and we're saving that value and we're feeding it into another solid, which is then in turn getting fed into yet another solid. And then the pipeline is associated with certain modes and certain presets, and you can add tags and descriptions. So next slide. So this is kind of the visualization of your pipeline DAG within the Dagster UI. And this was going to be much more fun with the demo at the end, but we'll let your imaginations run wild with this. And so you can see that these are the different solids tied together, and they have, when we're chaining them together with the outputs they generate, and you can see what all parameters are needed to run each solid. So next slide. So this again is within the Dagster UI, and this is how you can set those parameterizations or those parameters for certain solids. So if based on the last slide, like most of the solids take input from upstream solids, but some of them require additional parameters. So in order to actually run this pipeline, we need to set those values as well. So you can just set these and change these at execution time, and you can save these configurations, and this is what presets are. Our presets are just these kind of predefined values for running your pipeline. So next slide. And this is just the modes of the pipeline. So kind of going back to what I was saying about using different versions of resources for different runs. So for our local run, we were going to use Snowflake, which is our data warehouse, but we were just going to use mock Snowflake. So we were actually just going to read files in locally that are just local CSVs and kind of pretend that they were the results of Snowflake queries. But in dev mode, we were going to use a real connection to Snowflake, but we were going to connect to just a staging Snowflake. And then if we added an additional mode for production, maybe then we'd actually be connecting to our production database. So next slide. So this is kind of just what I was saying of how we use our different modes and how this kind of helps get us through our development cycle very easily and kind of safely, that we can do a lot of local testing with just everything being mocked out. And this is really helpful for our unit testing. For dev testing, we can start to do more of our integration testing of our pipeline and connect to some of these resources, but maybe use sandbox versions of them. And then by the time we've done both these levels of testing, we can actually do our production runs. And if you've done a lot of like ETL work, this is just very helpful, because a lot of data work without a framework like this tends to be just throw it into production and kind of cross your fingers and see what happens the next day after the pipeline's run. But using Dagster, we can do this a lot safer and have a lot more confidence and catch a lot of our errors much quicker than by the time we're like ready to actually pull the trigger on something. Next slide. So the other thing that's helpful with Dagster is you can configure the instance for different environments. So we have 4 main ways we kind of deploy Dagster. One is just locally within a virtual environment. One is within a Docker Compose. One's on our AWS Dev account, and one's on our AWS Prod account. And these will kind of make more sense in the next slides. So our local dev environment is just running, Dagster, the Dagster project locally. So we can just run this locally within our virtual environment. So we'll have all the Python dependencies it needs. And we can, at this point, just on localhost, go into Dagster and execute runs. So on the next slide, this is what it kind of looks like running locally. So you can see that our repo is running, but some of the Dagster peripherals, such as the scheduler and sensors, are not running at this point. There's a separate Dagster daemon process that runs that handles scheduling and things like that. So next slide. So then in our Dockerized setup for Dagster. So this is still on our local machines, but we can start to get to what this would look like to actually be running Dagster in more of a production environment, because now we have Dagster running, we have a Postgres instance running to capture the metadata, we actually have the Dagster daemon, and at this point we've actually start to spread out the workspaces of the various workspaces in our Dagster account into their own gRPC instance running within the Docker Compose. So this is helpful for, again, those workspaces can all have their own dependencies, so they can have their own Python dependencies and any additional dependencies that are necessary within the Docker image. And this just makes it so that you can have pipelines more finely tuned for what you the specifics of what needs to be run, and don't run into as many conflicts. And then in terms of there's a concept of Dagster of a launcher, and that's what executes the pipelines. So at this point, we're using the Docker launcher. So when we're executing a pipeline, it's starting up another Docker process and running the pipeline in that, and we'll close it down when the pipeline's finished running. Next slide. So now you can see that in the Dagster instance, what's actually running for this Docker Compose setup, I'm running our BI workspace, but I'm not actually running our data science workspace because I'm not working on it right now. So that's failed, but Dagster is still running successfully, and it's still running with the BI. And you can see that the scheduler and run queue and the sensors are running. Sensors are just a way to do more event-driven pipeline executions. Next slide. So very quickly, this is kind of how we start. This is Dagster deployed on our AWS account, and it looks similar to our Docker Compose setup, but now we're starting to just use more AWS resources. So we have a load balancer in place, and we have Cognito in place for authentication of the service, and we have Postgres running on Aurora at this point. And so all of this is just managed in Terraform. So this is where we start to get a sense of just like how Dagster will be behaving in production before actually pushing it out into production. And so I think my next slide should look pretty much the same, because it's the same AWS stack. We're just running it now officially in production, as opposed to our AWS dev account. And the only other difference is we have an ECS launcher. So instead of these processes happening within the same node in ECS that's running the gRPC, they'll run in a separate task and then spin down when they're done working. One thing that's nice about Dagster is all this configuration is pretty flexible. A lot of Dagster is geared around Kubernetes because it's a data project from the last 2 or 3 years, so it's a lot of Kubernetes, but we're not quite cool enough for Kubernetes yet, but we are still able to get this run with just plain old ECS, so that's been nice. And I think the next slide is my demo, which isn't happening, but still a great image. But yeah, so kind of a letdown on the demo, but yeah, thank you for listening to a quick overview of Dagster.
Thank you so much, Dennis. We really appreciate you. I know you have to run. The only question I saw in the chat was, I think Ray was trolling you about Snowflake. He says you're a big fan.
Yeah, I don't get to do as much Snowflake as I used to. It's a lot more Dagster now, but Ray and I have a lot of good Snowflake memories.
Well, thank you so much for your time. I will go ahead and introduce our next guest. So coming up is Ray Berg. So I'm sure just about everybody here knows him if you've been in Chippy for any amount of time. He's going to go into some details about why you need job orchestration, and then specifically into some overflow. Airflow.
Listen, we've got room for all of it, so no need to overflow. Yeah, that was a great intro. I think I don't even need to set the talk up, except maybe to say I think sometimes folks look at these talks and they're looking at different levels of depth. I think that was a really great, Dennis, thanks again for that really great talk that was sort of focused on in-depth practical application of the tool. I kind of want to take a step back. I usually like to give more fundamental foundational talks. And so I'm going to take a step kind of higher up and start from sort of first principles on why do you do this stuff in the first place? Why are you all here? And I think it's good to remember sort of what that use case is. And it was kind of fun to see sort of that, how it plays out and where it gets to with Dagster. So you should be able to see my slides. We're going to focus mostly on workflow orchestration, and I'm going to start with some history. I love Greek myths specifically. When I was a kid in the 4th grade, I got this book from the library in my elementary school. I checked it out like constantly. I just recently bought this as the edition that I used to read when I was a kid. And it's got all these kind of cool pictures and diagrams of Greek myths. And in it are the stories of sort of the first gods, right? The heaven and the earth. And then the next wave of gods that came along that were a little bit more complex. And here is a god that came along in that second wave. And what I like about talking about things like this is we are always looking sort of to improve on processes, even when we tell stories. And in telling the story of the first gods in Greek mythology, the pre-Hellenic gods, you have these really foundational things, heaven and earth themselves, right? And the heavens kind of control everything. It's the sky, it's the clouds, it's the storms, it's the seasons, it's everything. It's the stars that let you track time. This god came along and became sort of known at the time as the god of the harvest. And it was because I like to think that he stole something from his parents, from the heavens themselves, from Uranus, stole the reading of the clocks, right? We get sort of our sense of the clocks from the cosmos themselves. And so we start to figure out, wait, around this time of year, whenever that star is in that location, I should plant the wheat, because that tends to mean that the storms are over and we're ready to go into planting season. And then we can have a longer planting season if I can predict that date. And if I can predict that date, then we can get a better harvest or bigger harvest, and I can get more goats, which you can see the goats in the background there. With the harvest comes the scythe, and that's what most people know him for at the end of the year, kind of celebrate with Cronus. Father Time is this figure who comes and collects the wheat and goes on with life. And Cronus became the greatest god because he figured out, well, the stars are kind of simple. I'm going to think more complexly about time, and I'm going to control agriculture. But we always make improvements. And so Cronus as he came along, there were others that came along after him, and Demeter was his most logical heir as it came to agriculture. Demeter was this very clear god of kind of beginning of commerce a little bit, and focusing on wheat. Now, why am I telling you all these stories? It's because in data science and in data engineering, we have the same first principles. We have the same idea, these really foundational ideas that we all care about. And in the beginning, there's this this tool we use that's based on Cronus's name, called cron. And cron is how I think 90% of the world works these days. Still, it's written in, I think it was in 85 or something like that. No, 75 Bell Labs. And we have this really simple idea, which is if I have a schedule, I don't want to talk to you about why the schedule is the way it is, but if I have this schedule and I want to run some script, I can run that script on that schedule. So if I want to run a script at 1 o'clock, 3 o'clock, and 4 o'clock in the morning, I can set cron up to run the script. And so you have this person that comes in and runs the job, the daemon that runs in the background. And then the job is done, I can move on. So this might be a data process where you're pulling in some data and storing it at some other location, some ETL process that you're moving something from somewhere to somewhere else. And so you have the first one. That's great. Awesome. That's very successful. You make $100,000 with that first process that you have. And then the company says, oh, well, hey, let's ask, can you do another one of those? Take that first thing, let's add a second script just a little bit later. And we need you to take the data that you got from that first script and just send it over to this other group, but change the format a little bit, right? And you're like, well, okay, great. I'll just run it half an hour later. It takes about 15 minutes for that first job to run. So I'll run it 30 minutes later, and the process should be fine. No issues. Then they say, well, we get this big data load we need to do at the middle of the night. So at 12:10 in the morning a.m. every day, let's load this big data set from the day before and get it all ready, because we want a whole bunch of processes to use this. We've got a brand new idea for how to centralize our data or think about our data. And then we've got a whole bunch of other things that want to start using it. And so you add this to the cron server and you say, okay, I'm going to run this task. And then you say, well, I need a whole bunch of other tasks that now rely on that. So you say, oh, okay, well, if I need to rely on that task is pretty big. That task might take an hour, might take 15 minutes. Usually it takes an hour, maybe an hour and a half, 2 hours. On Mondays, it's really bad because it does the whole weekend. So let's just have it run every day, and then let's have a script that called wait for daily. Once the wait for daily is done, then we can go ahead and process the rest of the data. And you start to fill out your cron job. And now this works, right? I can write scripts that wait for other scripts. It's just scripts, just code. It all works. And you start to say, well, is this reasonable? And the answer is no, it's not. There are a new set of gods that are mad. They're looking at the people who came forward and go, wait, why is this working the way it is? Why did we set this silly process up to have all these cron lines that don't make any sense and have ampersands everywhere? And I can't follow the logic. And you get to 700, 900, get to 2,000 jobs, 5,000 jobs. It's not a manageable solution. And partially because you broke down the problem wrong. You thought these things were atomic and valuable by themselves, but they really aren't, right? Some of the jobs are connected. There's like 5 that kind of go together and make an application. And 2 of these things were created individually, but they actually need to connect to something else at some point. So we come up with a new concept of what an application looks like. This comes from Dustin Stansbury's blog on Medium, and it's a really good explanation of how Airflow works. So I'm not even going to bother trying to explain it better than Dustin did. Go check out his blog. I'll have the slides. I'll drop them in Slack after this, and you can click on the link. Really great example. I think everybody can kind of understand how this works, right? I have some ad revenue I need to pull in. It's a spreadsheet. I'm going to transform that. So I'm going to download it or extract it out of the system, transform the spreadsheet data, and then, oh, shoot, I need the revenue data that comes from each of the stores, the app stores. So I'm going to go to App Store ABC, go grab that data, turn it into JSON. Oh, shoot, we need to make sure that the currencies are on the right conversion, right? So let's go back and let's make sure we get the currencies. Oh, wait, the currencies aren't available for the day. Let's go download the currencies first, make sure those get in. Great, then we can combine those with the App Store data. Then we can take that from the network revenue, and we can merge it all together. Then we could feed that in, maybe think about historical data and make a prediction about tomorrow, how we're going to process or how we're going to do whatever, right? Whatever your business does, that's what you do the next day. And you say, oh, this is pretty good. And we've kind of geared ourselves to think about problems like this, think about flow charts. Even, you're a kid and you learn to make a peanut butter sandwich the first time. You get the peanut butter, you get the jelly, you put it on the table. You sort of think in flowcharts sometimes, right? If you can break it down. First do this, then do this. And then somebody else could be doing this and get this in this place. A long time ago, we might have had just a straight list that says go from here to here, but data systems get more complex than that. You want to have things running in parallel because if you ran them in serial, even with a really big, beefy process or with multi-threading in each process, you're not going to be able to do all of it in a day. So we've kind of built a world of engineering around us that thinks about things in this problem type, this sort of framework. You can call it flowchart, but it's a simpler idea. And that's what I want to get to. And so whenever you're talking about workflow orchestration engines, it's really key that you understand a term that we use called Dags. So I'm going to talk a little bit about graph theory for just a second, just because I never want anyone to ever think that the word DAG is scary. It's really not. It's very simple. So a DAG comes from this mathematical concept called graph. And a graph is a thing where it's a model of a construct, a way of thinking about a problem, where you divide your problem space up into 2 concepts. You have a node, which is, think of it like a circle or like an object, and you have an edge, which connects to another node. That's it. It's not any more complicated than that. You can have as many nodes as you want. You can have as many edges as you want. That's a graph. So graphs are anything from, if you had a taxonomy of animals, right? That could be a graph where, ducks are more closely related to geese than they are related to rhinos or something like that. You could have a graph that's all the cities in America, right? Like where are they laid out and what are the roads that connect them? Every city is fundamentally a graph with the interstate system that connects to other cities, right? That's a graph. You can solve problems that way. So that's it. Just simple thing, object or a node, and edges, the lines that connect nodes together. So the next part of graphs that we're going to need to know is the part that talks about direction. And so a directed graph or a digraph, They're commonly called. I think it's a cute term, digraph. A digraph is a graph that has arrows on each of the edges, just connecting the nodes together, right? Very simple concept. Obviously, if we have something, let's imagine a water slide. So water slide, you want to ride on the water slide. You need to get to the top, then you need to get on the water slide, and then you come out the bottom, and then you need to get to the top again, right? So that kind of direction, there's a flow to it. If you want to make a pull request on a code base, right? First thing you do is you write your code, then you make the PR, then you pull request the code into the code base, and then you make more code, and then you pull go through that process again. Directed graphs just mean you flow from one way to another. They're commonly used in computational theory for like finite state machines or anything that sort of says, go from here to this. Like this goes to that. This has this kind of relationship with this other thing. So directed graphs are just graphs that have arrows. Directed acyclic graphs are directed graphs or digraphs that don't repeat themselves. They don't have loops in them. They're acyclic. They don't have any cycles. And that's probably the easiest to understand, right? The water park might not want to keep track of the fact that you might ride multiple times. They might just say, hey, when they scan their wrist badge, they are going to start a ride. They're going to get on the ride, they're going to get off the ride, and then they're going to be done. And who knows, maybe they'll come back again, but I'm going to treat that as a separate business process. A user may come to our website and they may click on a link. They may walk through a checkout flow. But I'm going to keep track of the fact that that user did that one thing. And then maybe I'll aggregate all of the runs or all of the individual graphs together at some point in the future. But I just want to think about the simple concept of this, this, this. And that's really where we get to sandwiches and making a peanut butter and jelly sandwich. A peanut butter and jelly sandwich is a directed acyclic graph because you never repeat a process. You never get back to the beginning unless you forgot to add too much jelly or peanut butter, right? You want to get a little bit more on there. But that would be in a single step. So you get your bread, you get your peanut butter, you get your jelly, you apply the peanut butter and the jelly to the bread, and then you eat that sandwich. You don't then go back and make another sandwich. That's a whole other process, right? There's no cycle in that. That's it. Directed acyclic graphs is a good model for thinking about problems, right? So going back to our high-level analysis, does that fit? Is that the term that we're using? Are we using it correctly? Well, we have nodes, operations that need to happen. We have edges, things that connect them. Those edges have directions. They go in one direction. Before you get the daily conversion rate, you need to make sure that it's there. So wait till the conversion rate's there, load the conversion rate, then perform the currency conversions. That sounds directed. And then at no point does an arrow take you back to an earlier step. So that seems acyclic, right? There's at no point can you follow the line and then get back to a point that you were at earlier. Easy. This is, I think, a DAG. Very simple. So from this point, we can convert this and we could say, okay, we have a DAG. I hear airflow. I hear the Dagster. I hear all of these tools handle DAGs. How do we convert them? And Airflow allows for you to think about these things and convert them. This is my animation budget, by the way. There's no animation. There's no budget. We're just going to draw lines between the things. But I can convert what is an abstract flow into an Airflow DAG here without a problem. And so let me flip the view here. Again, you can tell I'm nothing up my sleeve. I'm just flipping the shape of the slides here. So I can make this change. And nothing really has changed about this except this is being rendered with Airflow. This is showing me that each of the operations is being performed in order from left to right and is going to complete when the predict revenue is done. Each step has to happen before the next step can continue. If something has a dependency, it's what we call it, the line between them is dependency. If something is required before something else can start, you have a dependency. That's it. We're done, right? We have a DAG. It's in Airflow. So let's think about that schedule again, that idea of cron running every day. Supposedly, this is a better system. Supposedly, this is more useful, but we need to have it on some schedule. This is just one run through a process. So applying that same kind of cron-like schedule to it, we can say, okay, we want to run it every day at 10 minutes after midnight. And then what do we do? Okay, well, shoot, we have this DAG, and it's all about nodes and edges and things moving through time. That gets complicated, right? That's how do I think about this, and how do I think about it as it moves through some weeks and months and years of the company. So what you need to do is you need to think about taking this and flipping this graph and flattening it so that I can reason about it as a human being. And Airflow does that. It provides you a way to see this graph tilted sideways such that all the tasks, all the operations that are happening are visible on a vertical line. And this allows you to kind of walk through and say, okay, well, what's the status of this for a given run, for a given day that this should have run? It was supposed to run yesterday. Something went wrong. We need to run it again. It's going to run tomorrow at this time. We could check the status tomorrow, right? Very simple concept. Nothing really strong there. In the database behind the scenes, it's storing a record for each of these things. There's a DAG run record. There's a task instance, which is a single, it basically connects this task is supposed to run on this day for this DAG run. And this DAG run is a point in time for this DAG. And those things are just stored in the database, and Airflow can provide those to you. I don't really love the way that they sort of talk, Dustin. If you're out there, Dustin Stansbury, I think you did great. Except I don't like that we sort of call out operators being separate from sensors. That's the same thing. Fundamentally, Airflow is the nodes are all just operations that need to be performed on the platform. The operators are, like in Dagster, the solids. The operators are the types of code that need to be run to call a task complete. The task is just a name. It's just a reference. This DAG has this task. That's just a moment in time that needs to pass. The operation or the operator is what is actually going to be performing that function. So where does this all fit? Let's zoom out a little bit and just take a look at the UI. Each of these kind of concepts is embedded in the Airflow UI underneath one of these kind of links. You can go to the Airflow UI when you fire it up on your computer. You can see, okay, I have a DAG that's running. I can see it running by day or by hour, or by minute. I can see each of the runs. I can track its progress through the system. And that's it. It's provided. It comes out of the box. Most of these tools, Luigi, Uzi, Azkaban, all of them provide this kind of interface. This is Airflow's. Airflow is an Apache project. And provides a pretty useful way to look at this data. So I think I've explained sort of how to think about moving your process into something like a workflow orchestration engine, something like Airflow. But how do you actually make that code? In the last talk, you saw a little bit about how Dagster does it. It's pretty much the same here. They're all kind of the same concept. You need to be able to define some simple concept of a workflow or a pipeline. And you need to be able to assign code to execute in that pipeline. This is probably one of the simplest ways to think about Airflow. If you had, this comes from the Astronomer, which is a service provider of Airflow. They host your Airflow for you. They have a really great couple articles here, and they explain, here's how you would write a DAG. Here's create a DAG, has a couple of, has a schedule attached to it. There's some helpers like daily that are really useful. And then I only have one task in this case, and it's a Python operator. And when that task runs, I just want you to call this Python function. So it's a very simple kind of language. And what Airflow does is it kind of runs along and it tries to find all these DAGs and pick them up and stick them in the metadata database. It stores them in the Airflow system itself. And then you can come back and basically run that code later as a worker or as show it to the user as on the web server. So that's a really simple DAG. What about the DAG that we created? Well, I don't really, there's a lot of code here. It might take a lot to kind of write all this stuff out. But at a core level, you might have some, hopefully you can see my my cursor here. You might have some create task function that generates one of those operators for you. And that's the extract add revenue. And then you just need to define the relationships, right? Each of these would be the nodes. You now need to just get to the edges. The edges are defined using the bitwise operators in Python to say extract add revenue needs to happen before transform spreadsheet data. It happens before combine revenue data. You can chain them together. You can also do multiple on a line. If you had like an array, you can say these happen before this, happen before this. And this is what kind of builds that tree up for you. As Airflow is going through, the scheduler is combing through the files and says, oh, I found a DAG. Oh, it has all these dependencies. I need to run them in this order. So Airflow, I sort of talked about, each of those. Well, let's go back. So these are the tasks that need to get created, but what are the operators and what are the operations you can perform underneath? There's a ton that are built into Airflow. And there are a bunch of modules that you can download or build on top of it as well. There's open source sort of operators all over the place. And then your company will have your own, right? You'll have ones that you like to use. But there are a lot of really common ones. So imagine you want to pull something from you have a Hive metastore and you want to pull something into a time series database, you can Hive to Druid. If you want to do something, you have Presto running and you want to, actually, does it have a separate one? Okay, so if you have a Presto server running, it's kind of masking a bunch of different things, but you've got your own analytic database written in MySQL, you can run a Presto to MySQL and they've kind of figured out the basics for you. And if you don't like the way that works, you can inherit from that operator and you could make your own and you could change the way that it behaves. Like I said, operators are like the operations. They're the nodes that you're going to perform. They're the functions that are going to get executed. And it's all kind of built in. There's a lot of cool stuff built in. And sensors are often called out as a separate thing, but it's really just a type of operator that just has a little bit different interface. I'll show you how to write your own. But it's basically saying, I'll wait for something to be true before I allow something to proceed. So wait for this to be available and then do something that performs with it. But a lot of cool options, like parameters that are built into this stuff. There's, the basic ones are the Python operator. You can write whatever Python code you want inside of there. You get some access to the way that Airflow runs the code. And then you can, build sort of whatever you want. You could build an entire Python application behind something. If you want to, you can make an operator that just stands up a Flask web server. It'd be a terrible idea, but you could do it. You can do anything. You can do whatever you want in Python. You can stand up behind that process, and that process will run. I think that's kind of all what I wanted to say about this slide. So imagining that you did want to get in, you say, okay, well, great. You're hand waving about operators and sensors. You're sort of saying it's all built in. Just trust me. No, you can build your own. It's not that hard. I wrote these last night when I was thinking about this talk. On the left, you have just a generic operator that's called like a do operator. And you can see that Airflow has a built-in that uses Jinja 2 for templating. So you can have template fields that get automatically rendered when a task runs. And then you can have, you can pass in different things. So here I have a DAG with two do operators. The first one has a do ID of I did the first thing, and then it uses the Jinja templating to get access to some Airflow variables. These are called macros, Airflow macros. You can look up all of the macros that are available to you, but they get rendered. And so on the bottom of the screen here, you can see it gives you a description of what it did. I did the first thing, and the DS translates into it ran yesterday, right? The second final thing, and it's the same date, but I removed the dashes, right? No dash. There's a couple of built-ins that are kind of really nice for building file formats and stuff like that. So an example might be, I want to download something from some web API, and I'm going to store it in some file path, and I'm going to run that every day. And so I want the file paths to be unique. I want them to be DS no dash for every day that I download the data, right? And that way I can have a file system that's got each of the file paths, each one gets downloaded. Some great questions coming in and some great answers. Feel free to crowdsource. I'm happy to come back at the end. So the operator or the sensor is another one. That's on the top right here. And the sensor is really the same kind of thing, right? It's like, hey, I'm going to run a thing, but instead of calling execute, sensors call poke. And you poke a sensor and say, hey, are you ready? Are you ready? Are you ready? Are you ready? It's very annoying, right? Are you ready? Are you ready? You can set how long you wait between when you get asked whether you're ready. Parents, you'd love Airflow on car trips. You can set the poke interval to be 2 hours instead of 5 minutes. Are we there yet? Are we there yet? Are we there yet? But you can set it to whatever you want. And then at the end of the process, if the poke comes back with true, it must mean that the sensor has passed and it can move forward. And if it is false, and if it's false for too long, or if it's false too many times, then it will fail. And so that can give you a clue that something's wrong in my process and I'm holding up at the right place. And this is true, again, I'm kind of describing Airflow, but really this is true in most of these systems. Airflow is just an open source Apache supported platform that does this stuff. So the next part is hooks. So I've talked a little bit about sensors and operators and how this is kind of the structure that Airflow runs in. The last thing that I think is interesting to talk about from a mechanical perspective in Airflow, and it's true in most orchestration engines, is hooks. All of these engines, unlike cron, have figured out a way to make getting access to your data sets easier. They've all figured out a way to have a factory style API that says, I don't want to think about usernames. I don't want to think about passwords. I don't want to think about client authentication keys. I don't want to have, I don't want to verify the server key. I don't want to do any of that stuff. I want to say, Airflow, can you give me the prod user? Can you give me the sand user? I need to go do some stuff in sand. I need to go pull some sand data. And the hook allows you to get an object factoried up that gives you direct access to that with the credentials embedded in the object. And so it's really easy for a developer to come in, a new data engineer or data scientist, to come in and say, oh, hey, give me that MySQL connection. I really need that MySQL connection for this analysis I'm about to run. Or give me that whatever. And they're not storing, you're going to love this part, they're not storing passwords in GitHub. They're not storing them in their Docker end files that they check in. They're not leaving them on their host. In many cases, they're relying on the deployed server to keep track of that stuff. And that's managed. It's a nice little API that's managed against environment variables, or you can store those credentials right in the metadata database. I mean, I didn't really focus this on talking about the metadata database or about the system structure, because not everybody's interested in that stuff, but it seems like a couple of people might be. So from here, you can decide what you want to do next. There are some things to think about when you're trying to build scaling into your workflow orchestration engine. In Airflow, there's a couple of terms that are a little bit overloaded. So on behalf of the project, I'm not a part of, I'm going to apologize for them. Parallelism is a word for all of the system, the entire cluster, all of this Airflow deployment will let you run 100, 500, 1,000 tasks at the same time. That's the Airflow parallelism. A pool could be assigned to a resource or something else. And so every operator could fit inside of a pool, or every DAG can fit inside of a pool. We use this for accessing tools like, well, I have in the past used this for accessing tools like Redshift, or tools where it's like, I don't want to have 7,000 database connections opening at the same time. So I assign all of a certain task type as a pool. And that allows me to get away from thinking about, oh no, the thundering herd of all these data things coming right at my production database or my read-only database backup, or, you know, the laptop that the critical business data sits on, whatever system you've got that you're afraid to have people directly hitting with a lot of volume. You can set that stuff into a pool, and you can say, oh, you only allow 6 connections at a time. Well, I'm going to allow 10 connections to this service or whatever. Max active runs is as I'm running a DAG, as I'm running my workflows, I can run 5 at a time. So maybe I want to catch up 5 days at a time. Maybe I want to do, say, I can run 3 of these at a time. Or, oh no, this is not a well-designed DAG. I can only run 1 at a time because it relies on some global state in my infrastructure. It relies on some system that can only ever think about 1 day at a time. And you might want to say that DAG can only run 1 at a time. Concurrency says, how many things can I run for a DAG? So imagining that I have a thing that pulls ad revenue data in, should I be able to run 5 ad revenue jobs at once? Should I be able to run 10? Should I be able to run 1,000? How much should this one DAG take up? How much should I allow? And maybe an administrator will be like, whoa, you're not allowed to go over 10 like simultaneous tasks per once, or 1,000 per once, right? Depending on how big your company scales. Task concurrency is the last one, which is a sort of, remember how I talked about the DAG runs? Like you have all these, you can have many DAG runs running at once. So say I run 50 at a time. I could do 50 days of revenue data at once. But there's this one task that happens in that flow that I really only want to run 3 of. You can do it at that level too. So there's a lot of like granularity here. I spent a lot of time talking about this. This actually doesn't come up that much. Just kind of shows you the flexibility of it. I think, you know, once you get beyond these sort of basic principles, you want to kind of start digging into really what Airflow is all about. And I think there's some really good posts out there. I found this fun one that's really concise. It's the educative blog intro, which is really like for Airflow, that's really nice. I haven't found a good article on execution dates. I find them to be the most confusing thing about most of this ETL world, right? But I recommend you really think about the concept of execution dates and start dates. Think about when you run your workflows, how do you bin up the periods that it's going to evaluate? Airflow has a good model, I think, but it's really hard to get into. It takes a long time for you to sort of center yourself in that. And I wish there were better articles that just talked about execution dates to help people understand. The biggest complaint I hear people make about Airflow is that it seems great, seems flexible, seems rigorous, but people have a little hard time kind of contorting to fit it. And that might be true of almost every Apache project, because Apache is known for really great, really robust software that it takes a little while to sort of get flexible in. and people tend to specialize. There's a really cool conference talk from a long time ago. In 2017 at EuroPython, there was this great talk on design patterns for Dags, and they sort of focused on it, telling it from a rivers and streams perspective, which I really liked. It was kind of fun talking about tributary flows and I don't know, other types. And then there's this kind of bombastic one from Bluecore that came out a few years ago that's basically saying, should everything be a Kubernetes operator? Should Airflow just be responsible for spinning up Kubernetes pods and then moving off and doing other things? And that might be true, I don't know. But it is a fun thing to think about. My last slide, I promise, unless you want to see my backup slides, is what you should sort of take away from this talk. And I think the key thing about workflow orchestration is the only reason we do any of this stuff is because cron scares us, right? We have this looming figure, which is the grandfather time with the scythe, and we are afraid of it, right? We fear the idea of a 7,000 page cron script and a whole company driven by cron, and that stuff maybe not being checked into source code or that stuff not being available. And so we try to come up with better patterns to think about this. I think people they think that they work at a place or at a company where the how do I say this? They think that they work at a place that can design the right applications from day one. I've never heard of a company that's done that. I've only heard of companies that design the wrong application from day one, and then they ultimately get to something that's pretty workable. Some companies are better than others at that, but rarely ever, and maybe never, has a company said, I'm going to design the right consumer-facing application or business-facing application from the ground up on day one, and I'm going to have the right data story behind it so that we can do data analysis. Some data companies may be capable of that. I don't know who they are. So I think thinking about these data workflows and ethics, you're just trying to make sure that you're doing the right thing, something that's going to last for longer than a couple of years, but something that is flexible enough to change if you needed to. So Airflow is just Dags. That's it. It's not anything more complicated than that. It's got operators and hooks. There's some things in there, but like really it's just this, then that, then this, then that. It's not anything more complicated. Anybody can do it. And I have the instructions on the right side here. If you pip install upgrade pip, because there's a problem with pip around version 20.0.3 or something like that, and then you do pip install Apache Airflow, db init, create a user, run the scheduler, run the web server as two separate processes. The first one's in the daemon. It's up. It's running. You can see it locally on port 8080. That's all you need. It's not any more complicated than that. You can run it in Docker. You can run it anywhere else. You can run it however you want. But to get it up and running, to see what it is, to kick the tires, you just need these 5 commands. That's really all. I tested it on my Apple M1, so even with low-grade hardware support, you can do it. It's totally possible. Airflow is opinionated. It has a bunch of thoughts on how you should do stuff like this, and some people don't like that. It's worth thinking about, but it is becoming a pretty fast standard. Composer and the Amazon product and astronomers obviously out there have been doing stuff for a while. A lot of folks are kind of centralizing around this because there's power in numbers, right? The effect of being able to swap engineers and swap paradigms and ideas is pretty strong. And Dagster is as well, like leverages Airflow. You can do an integration with Airflow as well. It's a pretty cool thing. And it's great that it's written in Python. It's great for the Python community. But I think Python knows this as well. Python is great largely because of how many people want to do it. And Airflow is similarly great because I think people tend to like working with it once they start doing it. I've had a couple of people come to us and say, hey, we've been using this tool. I'd like to maybe use it more, right? It's pretty easy. It's not that hard to do. And so I think, it's definitely growing. It's not a place that I would count out anytime soon. I think there's a good couple years left in Airflow as a technology. Hopefully this gets rid of some of your fears of orchestration engines and workflows and things like that, and hopefully encourages you to go check out Airflow and try it for yourself, because it really isn't that hard. With that, I will stop talking and maybe take questions if anybody has any left over.
Yeah, I saw that Emily had answered a couple of them, but she
Thanks,
removed them
Emily.
because I think she wanted to know if you knew the answers.
Oh, Emily is testing me. Okay. What is Emily testing me about? Let's see.
So I think Michael's was first. He wanted to know what your flow charts were made on, what tool.
Well, the ones I didn't steal were just made in Google Slides. I didn't use anything custom. I plug for Lucid Charts. I think it's the latest thing. Like, it's a fun, nice tool to use. But I don't pay for Lucid Charts personally, so I don't use it for my personal presentations. But yeah, Google Draw's got some good stuff and whatever. Most of the stuff that you saw that you liked, I have links to who actually made them. Michael knows that I like to borrow and share credit, of course.
Oh yeah, and hopefully everybody's on our Chippy Slack, but if you're not, as Ray said, he'll put the slides up there, so you'll get all those links. Colin also had a question whether there's an Airflow database of metadata.
Yeah, so Airflow by default will use whatever SQLite database, but it commonly is used with MySQL or Postgres. I think the way to think about that, I actually hate that they call it the metadata database, but I suppose it makes sense if you're thinking about things from a data engineering perspective, right? Your data, the things that you care about, don't exist in that by and large. That just describes the flow. It's really the application database for Airflow. It is how Airflow manages tasks and task instances and DAG runs and all that stuff. There are things like variables. There are things like this thing called XCOM, which allows you to push things across. And so I think I forgot the terminology that Dennis used in the first talk for Dagster, but there's this idea that I want to be able to pull a single value out and send it across. And so what Airflow will use, it'll store that value into the metadata database, and then a future task can pull it. So an example might be pull the standard deviation for the data set from dataset 1 and push that onto the stack, as it were, onto the database. Something else can then say, hey, what was the standard deviation for dataset 1? And it can read that off of the database and use it just like a value later on without having to think about the handoffs that much. But by and large, that database is just for Airflow. Usually when people think about workflow handoff, they're thinking about, should I store files locally? Should I use S3 or some other object store? And I read from data and I write from data. I put it in different locations. I love recommending to people that they use artifacts over process. Maybe you store it in a database. Maybe there's some like ETL database where you keep some data in, but keep your artifacts kind of separate and persist them for a day or a week or a month, however long you think you might need to redo it. Because being able to click and clear a workflow is amazing in Airflow, and not having to say, oh, shoot, the data was missing on Tuesday and we forgot this check and we'll fix that problem, but I need to rerun the data. It's 2 button clicks for an engineer rather than a half day to figure out how do I manually run each of the steps in order to get the thing out the door. Right.
All right. So one final question. I think Colin was wondering if this Airflow, I believe, sits on its own server, or does that just depend on your own implementation?
It does. I have a slide here if you want to push this up. This is from the Airflow basic architecture. I have a whole bunch of slides here that are extra just in case people want to talk about stuff, but the core concepts are there's a web server that runs it could run on a server or in a Kubernetes pod or whatever. There's a scheduler, and there are workers. The scheduler and the workers can be combined, but there have to be, if you want the web server and you want the scheduler, those have to be 2 separate processes. Whether you run those processes on different servers or run the workers somewhere else is up to you. There is a guide to sort of scaling your application out. This is kind of a common flow, I think. This was from Clairvoyant, where they recommended that you have a single parent node. Forgive the terminology, it's a little dated, but they have a parent node that has the web server and the scheduler kind of co-located because those are both pretty light on their own. And then they use this database on the back end, but they use a queue like Redis and Celery to communicate with all the worker nodes. And you can then span those things out. You could have 600 worker nodes, each one running 700 processes if you wanted to. Maybe not 700 processes, maybe 32 processes, depending on if you got a bunch of cores. But yeah, you can configure this however you want to. As you saw, you can actually run it in one terminal window, right? The slides that I shared earlier here. You just run it in one window because the Airflow web scheduler runs as a service in the back end. So it's really like you don't need more than one terminal window to do it, much less a server. You can do it locally, but most people would run each of these, the scheduler on the server and the Airflow web server on one or more servers, and then the workers on one or more servers. So it looks like, Colin, maybe that was an okay answer. Hopefully this was helpful for folks.
Excellent. Yeah, thank you very much, Ray. As someone who's very new to this topic, I can attest that this is excellent context.
Awesome. Well, great.
So I'm going to add James now, who is going to, you're covering Prefect, is that right?
Yeah, I'm ready to do it.
Okay, so what you can do is if you want to share your presentation, or if you have any materials to StreamYard, then I'll post it to the window.
Okay, got it. Seems like I was just able to share my screen. Is that okay? Does that work? That's like a, is that working? Okay, that's working. Great. All right, thank you, Ray. All right, let's try that again. Great. So let's talk about Prefect and not see a million of those. Beautiful. All right. So my name's James Lamb. I'm an engineer at a company called Saturn Cloud. We do stuff with Dags and Prefect, and I'm here to talk a little bit about what Prefect is. So first and foremost, I'm not affiliated with Prefect, the company, nor am I affiliated with the open source project at all. I'm just a fan and a user. So as you saw in the previous conversations, the previous talks, this is what data engineering looks like. It's circles and arrows. This is one of my favorites from one of my favorite Twitter accounts, Vaguely Reassuring State Machines. If you've never seen that, I recommend that you apply to it. That you subscribe to it. It's very soothing. No, but seriously, data engineering actually looks like this, right? It looks like turning requirements into code that you hate, that you run regularly to do stuff for the business. And when you do this work, right, you're working with computers, and computers are horrible. And so you end up writing a ton of defensive code in these pipelines. You end up try accepting things and like writing a ton of logs proactively to be sure you know what happened, and patching and fixing things, because when you see talks or you read blog posts about data engineering, you often will see these like very kind of self-contained examples. But whenever you're working, in a real world application with these tools, Luigi, Prefect, Airflow, et cetera, you have to integrate with the outside world. You're getting data from other sources that you don't control. You're writing artifacts to things you don't control. Maybe you're installing packages from package managers, and that means that things can break. And you end up putting a lot of effort into this other sort of work to just make sure that the thing can handle problems, or that at least when problems happen, you know what happened. So this is where Prefect comes in. Prefect describes this type of work as negative engineering. So this is like, if you were to describe to the management of your company what your kind of pipeline does, what your ETL does, you're probably not going to say, well, yeah, like here's where I write all my logs, and we checkpoint after every step up to S3 so that we can recover from failure, et cetera, et cetera. You're going to describe just the business value, right? Like we get data from these two databases, we smash it together, we make these plots, and we email them to people, something like that. All the other work besides that sort of executive level description is this negative engineering work, this work that is designed just to basically deal with the possibility of failure and give you good confidence that you'll be able to recover. And this is the type of thing that Prefect claims to be, let me say that again. This is the type of thing that Prefect aspires to factor out of your code into their framework. So let's look at what Prefect looks like. Similar to these other Python frameworks, your tasks are represented in Python functions. You decorate them with a little decorator that comes from the framework, and then you batch them up together. So in Prefect, your collection of steps to do your work is referred to as a flow. And then you separately manage when those steps are executed. Those executions are called flow runs. So you can see a small sort of subset here. I've defined some function, I've done whatever, and then I've wrapped that up into a flow object. But hopefully looking at this, if you are familiar with Airflow, you should be really excited about this, because check it out, right? My task here is returning data. This is returning a NumPy array that is then being consumed further downstream in the pipeline. This is one of the killer features of Prefect, and one of the reasons that I really like it is that you don't have to deal with this concept of like, well, tasks mainly just return statuses or very tiny metadata, and you have to write a bunch of code to like checkpoint other data to other places for other tasks. In Prefect, you can write data-defined flows and put large data sets on the wire between tasks. So I think that that's a really, really powerful concept. You should also see, if you're used to the Airflow API that is like, set upstream, set downstream, et cetera, that's not what Prefect code looks like. Prefect code looks like calling a function to get a result and passing that result to other functions, pretty similar to, just regular old Python code, which is cool. And then you'll also have this concept in Prefect called a parameter. Parameters are a special type of task implemented in the Prefect framework that allow you to run basically different versions of your workflow with different values of parameters without setting environment variables. So they're like a first-class thing that's different from an environment variable, and without any code changes, which we'll see in a second. While you're doing development work, while you're just testing the flow, you do not need to stand up any servers. There's no database, there's no like scheduler servers, none of that stuff. The flow object you create in Python code, you can say, run one instance of this flow right now with the flow.run method, and that'll just run directly in the Python session that you're in. You'll get to see logs, you'll get to like see what's happening. It's really, really nice. When you've built those workflows, those are called flows. If you have GraphViz installed, you can also see sort of a schematic of the graph. You can see the data dependencies between tasks and the order of them just by running flow.visualize right inside a Python process. So again, no need to stand up any sort of external service to visualize the flow. You can just do that directly in your Python session, which is sweet. And yeah, there are a ton of other reasons to love Prefect. So I just want to go over a few of them, but I'd be happy to answer questions after this about more. There are a lot more. So the biggest one, again, is you can pass data directly between tasks. So with the XCOMs concept in Airflow, for example, because the data that you pass around through XCOMs has to go through that one database that all of Airflow is running through, it's not really like a very appealing proposition to say, I am going to serialize like a 2 gig pandas data frame and pass it between tasks and write it in there. But in Prefect, that's no problem at all. It's actually an encouraged pattern. And that's because in Prefect, data, it's expected that tasks pass data back and forth between each other. And passing data back and forth doesn't necessarily have sort of like noisy neighbor effects on other running flows, which is sweet. In Prefect, you can really easily do multiple flow runs at the same time. So this is one of the things that I really struggled with working with Airflow, was that everything in Airflow has to be on a schedule, right? And so you can like work around making things not be exactly run one instance of this at some regular interval, but I found it to be really difficult in previous jobs where I worked with Airflow. In Prefect, the idea of a schedule is sort of a special case. It's like, yes, this is one way to say when you want to run a flow, but the entire interface is more sort of event-driven, right? It's sort of just like, there are many ways to say, please run this flow right now, and with possibly different parameter values. So I found that interface is a lot more flexible. It's really, really nice, especially for development. So when I've developed integrations with Prefect, it's great to be able to just say, like, here's my flow, run it right now. Or run it with this run it 5 times at the same time, each with different parameters, and like, let me see what happens, which is great. In Prefect, there is a very, very clean separation between sort of management of flows. So that's like scheduling when they should run, doing log aggregation, reporting statuses, et cetera, et cetera. There's a really clean separation between that work and the work of actually running the flow, actually executing your code. And you can basically run that sort of, shouldn't even call it a scheduler, that sort of manager. It's called the Prefect server project. You can run that directly yourself if you want. There's like, you can Docker compose it up, you can run it in a local process, whatever. But there is also this service Prefect Cloud, which is, I found it to be very high quality, very affordable, that basically will only do that scheduling piece for you. So it will do the piece of like, basically figuring out when to run your flows, giving you an interface to manage things like users and secrets and viewing logs. But that service never needs to have any access to your code or any of your data, which is really cool. And then finally, in the Prefect world, I found that they have an amazing and very responsive support community. I actually have a friend who recently got hired at Prefect, and I would say 80% of his job description at the company Prefect is literally respond to users in the Prefect Slack and on GitHub and answer their questions. It is amazing. You will get very, very high quality answers in their support community really quickly from the engineers working on the project. So these are all sort of reasons to love Prefect. If you want to learn more, if what I gave you is like a little bit enticing, I really recommend that you read this blog post, Why Not Airflow? I really didn't intend for this talk to be like a very hostile anti-airflow talk. That's really not really the intention. But I found that I understood Prefect best when it was explained to me in airflow terms because I was familiar with airflow. By the way, one of the creators of Prefect and one of their executives was an early contributor to Airflow, an early maintainer of Airflow. And in this blog post, some of the lessons that are described are lessons that that person learned from being an Airflow developer and then sort of applied at Prefect as a sort of like chance to do some things over that person wished that they had done differently with Airflow. So hopefully that is enough to entice you to check out this blog post. There are 2 more things I want you to do. If you're mildly curious, you should join the Prefect Slack. The Prefect Slack is amazing. It is not full of like sales pitches from vendors. It is not full of people just posting the very end of a stack trace and saying like, hey, I got this value error, what happened? There are really, really interesting, deep discussions that happen there. Much of the discussion, probably the majority of the discussion there is troubleshooting. It is like, here's what I did and I got this problem. But I have learned so much clicking around, reading the threads in that Slack. And Prefect, the company, is really, really intentional about the way that they curate this community. They push people to use threads. They push people to move, large stack traces or code blocks into those threads. They are very aggressive about turning questions from this Slack into issues in their backlog on GitHub, or about making sure that threads are ended with, hey, by the way, here's a link to the relevant pull request. This is a great Slack. It is one of the best open source project Slacks that I've been in, or Gitters or whatever. So I recommend that you check that out. And then finally, if you want to play around with Prefect, and especially you want to play around with Prefect's Dask integration that lets you use Dask as the thing that runs the individual steps in your DAG in parallel, you can go to Saturn Cloud and try it for free. If you follow this link, click the button, you can play around with Saturn Cloud for free. Basically, you'll get like a hosted Jupyter lab with some sample notebooks, and you run them, and your flows are going to run on Dask, and it's a lot of fun. That is the extent of what I wanted to talk about with Prefect, just really quick introduction. And I would be happy to answer any questions now or at any of these places if people have them. Thank you. I can't hear you.
It helps if I unmute. So James is a member of the Chippy Slack community too. So as he just showed, you can Slack him questions. I didn't see any in the chat, but I was wondering, from your talk, I got the sense that Prefect is very new. Do you know about how old it is?
I don't know for sure. would guess I've been working with it for a year. And so
Okay.
I feel that it was at least 8 months old when I first met it. So I think it's probably on the order of 2 years, but that I really don't know for sure. I really don't know for sure.
But I do always appreciate a good community for any tool that I'm using. That's one of my favorite things about Python in general. Like there's always answers and people who are willing to help, right? So I like that statement.
Yeah, it's been amazing. Honestly, the first time that I asked the support question in their Slack, their CTO responded to me. What? And it's not, I didn't know that person. It's not like there's nothing special about me. It just shows you like they really have been working hard on trying to build a business that also works with the open source project. And I found the open source projects is really, really fun to work on.
Yeah, absolutely. And then just sorry, I can't do a side question too. I saw that you were drinking a dark beer in your Slack profile. So, do you have a favorite beer?
My favorite. That's a great question. Thank you. My favorite beer is a River West Stein from Lakefront Brewing in Milwaukee.
Oh, local. Nice.
It's a really nice little brewery. If you've never been up there, they have an amazing brewery tour. Yeah, I think that's my favorite by far.
I think I have been there, but it's been years. I actually will go ahead and second that recommendation to go up to that brewery.
Yeah, it's a lot of fun.
So thank you so much, James. I really enjoyed your talk. I appreciate you rounding out the perspective on which tool might be the best for which people. So
sure.
I just want to say to everyone, thank you so much for attending this evening. This is my first time hosting. I think I'm taking over some big shoes because I think Allie did an amazing job before. I'll continue to improve, work on using StreamYard more smoothly. And if you ever want to chat, I'm on the Chippy Slack as well. My name is Natasha Polishchuk, and I'm a data engineer at Cresco Labs. So if you would ever like to present, we'd like to do these meetings about quarterly. So we'd love to get your input. You can do a shorter talk like James and Dennis did. You can do a full session if you've got a lot of ideas. So just hit me up. And then if anybody wants to keep talking, let's go over to Chippy Town. So let me just drop that link in the chat, and we can keep hanging out if you'd like, or just send me your thoughts and comments later. Thanks a lot, Ray. Yeah, great to talk to you guys. So I'll see you over at Chippy Town.